Okay, this is JJ and welcome back to my garage. I've been messing around with Fusion 360 for a couple of days and I found out a really nice thing, a good feature that I want to show you. When I tune my engines, I make new cylinder head inserts, and when you do that, I have always used my lathe to do this work before, and it's a little bit tricky to find the right volume. You have to measure, you have to try, and you have to remake it, and it's a little bit of a struggle to make them for me. So I'm going to show you a really nice feature here. And I'm also going to talk a bit about other things here also that's important. So I'm going to use, for you that already know about 3D software, I'm going to use a command called revolve to make this later on. So the rest of you, stay tuned. I'm coming to the good stuff in the end. First of all, I'm going to make. I actually measured the piston crown. It's a little bit rough, I know, but that is the best thing I know. And when I measure it from this, from the end, from the outer part of the piston to the piston crown, the height is about 2.7 millimeters. So I'm going to set up sketch a point here. That's 2.7 millimeters from the top here. I'm going to dimension it with D. That to that one should be 2.7 millimeters. Okay, now I have my point here. The piston has a radius, and if you want to have the very best squish band here, you should have the same radius on the squish band. Many times you can use an angle, but when you can use a radius, why not? It's a 3D software program. It's just to draw it up. So I'm going to set up a sketch arc, 3-point arc. Pick this point and this point, and I just roughly tune something in here. I don't know what it is. I dimension this because I know about that the radius is 350 millimeters. So okay, now I have the radius here. So about the squish band, I've seen people calculate the squish band in a totally wrong way. When you talk about squish band, you often talk about it should be 50% of the bore, and that is true, but it's not true. It's 50% area of the bore, it's not 50% of the bore. That's a huge difference, because if you calculate the squish band, just take the radius times 0.5 here, you're gonna have a squish band. It's like this, something 10, 11, I don't know, or 12 actually. It's going to be much too big. And if you think about it on a circle, if you calculate the area, if you calculate the area in here, it's going to be small differences in the beginning and bigger and bigger and bigger. So when you come out here, you get a lot of area because the circle is bigger. So therefore, when you calculate the squish here, you have to use another formula. I'm going to set up a point here too on this curve. I set it here, and I'm going to dimension it by doing this, this, and then I right click and take a line here. Okay, so this is going to be the squish band. And what about the formula? The formula is the radius times 1 minus the square root of 1 minus 0.5, that's 50%. So you take the radius times 1 minus the square root of 1 minus 0.5. This is the fine thing with 3D software programs. You can use the dimension field to calculate things in. So it's perfect. So now I see that it should be 7.41 millimeters. And this is a speed fight 100 cylinders. So it's the bore is 50.6. And on this one it should be 7.41 in squish to get 50% of the area of the bore in squish bound. Okay, what more? I need to have a volume here, so usually I just take the line command, and this is also a fine thing with this software, that you can click and you make a small straight, and when I click and hold down the mouse button I can curve like this. So usually I do it again, and you see then I get something that I can move on. So in this case I can change it like this, and this is good when you trying to calculate different kind of volumes here. So just roughly tuning in. Let's say we should have about 10 cubic centimeters of volume here. I just roughly tune it in. I don't know if this is going to be it, but we test it like this. Okay, now I'm going to use the revolve command. So create, revolve. I choose this model. The axis is what kind of axis I want to rotate it around, and it's this axis. And as you see now, it immediately puts up, I have full, it's 360 degrees here. You can choose full if you want to, it's the same. Click OK, and now I have my my head insert, as you see. If you've seen my movies before, you can recognize the shape. Okay, so this is of course looking good, but what about if you want to know the volume in here? Because this is the really important thing. If you want to have, you want to calculate the compression ratio. So what do I do? This is the final command. Here, down here, you have a command called boundary fill. And with this you can fill volumes with to find out what volume it is when you have odd shapes. And what I do first is to make a construction plane here. So I pick this face and I pull it up. Sorry. Pull it up 1 millimeter, because I know it was 1 millimeter height on this surface here. So now if we look from the side, oh sorry, it doesn't. I have to redo it, I think. Construct, pull it up. Sorry. Offset plane 1 millimeter. Now we show it. So if we look at it from the side here, you can see that the plane is like resting on the top here. And when you do this, you can now you can use this plane as a way to use this boundary fill command. So I take create boundary fill. I click the surface and the model, and then I get like this. As you see here, can select the cells. I select the upper part here. It's going to be just filling out the inner part. Select it and click OK. And now I can turn off this construction plane like so. As you see now, I have a volume in here. If we look at the bodies here, you can take away the outer part. So if you look at it now, you can see that I have the volume of the head insert here. And this is really good because I can just right click and use properties here and I can see that the volume is 9.2 square centimeters. And if I aim for 10, I can just go back to the sketch I used from the beginning. Okay, I have to find it. It's a problem when I use this radius. So now I can just drag this a little bit, I hope, like this. So, and try to find out if this is good. Okay, and I stop sketch, and now I have the body is already updated. So I right click the body here again, right click properties, 9.7. So in this way you can actually model up the insert in the way you want it. And the perfect thing about this later on also is when you have a CNC mill, as I have, I'm going to use this way instead to make the inserts. I'm going to use the cam part here. I mean, it's cam part in Fusion 360. I'm going to model up. I'm going to make the G code for a 3D program to make this insert instead. So that was that was the feature I wanted to show you. I'm pretty new on Fusion 360. At work I've been using Autodesk Inventor for many years, so I'm kind of used to 3D modeling things, but there's some struggle between Inventor and 360 in that way that shortcuts isn't the same, and this new joint they have put into the assembly part here, where you actually join components and constrain them to each other, is totally different from Inventor. So I struggle a lot with that. But anyway, I'm kind of used to the software itself, and it's perfect with the cam part inside. The only disadvantage for me is that my garage PC has to use Windows 32-bit, just because I use the parallel port to communicate with the CNC machine. So I think I have to think about the different ways of controlling the CNC machine in the future, because this program is really good. It's perfect for me as a hobbyist. It's perfect. It's free, and it's really great. So thank you Autodesk for making this awesome software available for me. So I hope you enjoyed this small little part, and thought it was interesting. There's more to come in the future, I think, on this Fusion 360 thing, because I'm going to try to learn how to use it in a good way. Okay, so see you next time. Thank you for watching.